Let me begin by just mentioning what this topic is all about. The topic that has been entrusted to me is green technology and biorefinery as potential assets. So I hope to give you a short insight on how we could develop this capability as potential intellectual assets. I work with the University of Malaya, and I am here based on the invitation from the ASEAN IPR Help Desk. And I just want to give a short insight into how clean technology or green technology can serve as a potential intellectual property. Now, let me give you a short outline of the presentation itself. I will be giving a brief overview of how a wise combination or synergy of science, basically biotechnology, which is involved in green technology or clean technology, and some practical business skills and some proper IP management, and how this relationship could work together, especially with IP regimes, and how currently the industry trends are heading towards, and how we could also look at some case studies and examples to draw some experience. Now, let me first redefine what green technology or green technology is all about. I'm going to use that term interchangeably. It means one and the same thing. And basically, clean technology can mean many things to different people. Now, inclusive definition would go beyond renewable alternative energy sources and to include retrofit and new energy technologies that relate to alternatives as fossil fuels, as well as environmental technologies related to reducing the carbon footprint and also mitigate pollution, and also overcome some adverse effects of waste treatment, and also to bring about some effective water treatment and resource management and many others. Now, what are some of the noble aims of these technologies? It is one, to reduce the environmental impact. And of course, zero carbon emission is another objective. And so that we could achieve some minimal impact towards climate change, and thereby probably offer some sustainable and environmentally friendly practices. Now, let me look at the current trend in clean or green tech economy. Now, worldwide, if you look at this segment of the economy, the development and deployment of some clean technologies do play a major role in driving many of the economies. And in terms of global policy, it is going to be adopted as one in the coming years. And as a variable policy approaches, it may persist, but a basic formula involves promotion of innovation, and how this could spur some commercial breakthroughs. And of course, finding the global market niche. And of course, in this, the role of IP has become increasingly significant. Now, let's look at some broad global trends. Where are we heading globally? The global venture investment spans something like a range of clean technologies, and this has contributed to some 600 diverse projects as far as the statistics in 2009 is concerned. And of this, the US received nearly 60% of this investment, and it is very clear that the drive for innovation and breakthroughs in the clean tech industry is a global effort. And of this, investments in Europe and Israel continue to increase in the last year. And within the region, we have Chinese firms accounting for some 72% of global clean tech IPOs in the year 2009. Now let's look at the regional scenario. Within the region, Malaysia has now caught up with the trend of grabbing a niche in these different technologies and heading towards commercialization of these technologies. The Malaysian Intellectual Property Organization has made some significant strides in this area to develop and regulate intellectual property across the board. And it is interesting to note that of all the institutions, the Malaysian public universities, each of them have their own innovation and commercialization units with significant number of patents generated, filed, and being filed. Now this is significant because in 1985, when I was first associated with the university, most of our research continued to remain in the laboratories. And there was hardly much of laboratory to field transfer. So that is a significant development. And if you look at the patents filed in the recent times, just 2 days ago, my own university, I was just looking at the list of patents filed, and it comes to a booklet of quite a number of significant patents. And it spans across a wide range of patents. Now, coming back to the private sector, this includes plantation companies that have also contributed significantly to the generation of IPs in green technologies. Now that is a significant pace of development. Now let's look at the region. Just across the causeway, we have the role of the Intellectual Property Organization of Singapore. Why I mention it is because I was at a conference there in August, and the number of players and also the scope whereby the IPs filed here can easily be filed also in Singapore because of the close relationship of my IPO with IPOS. And that will extend the geographical coverage of the patents and IPs. Now let's look at the business. The right choice of technology that is based on reliability and economy of scale and the shelf life retention and strength of the IP itself. And how do we achieve this? Now let's look at any of these technologies. If you look at the risks involved, we can say that the risk is highest at the scientific conceptual stage. And as it advances, as it scales up towards a commercial output, the risk decreases progressively from the state of development of the concept to a commercial plan, to the setting up of a seed company, and ultimately a mature company generating sales or profits. Now, spreading the calculated risk between, for instance, a university and an industry partner makes it very pragmatic in a venture, in a business venture. So, the question is, at what stage is the IP formalized? And this involves a protocol which involves different players and stakeholders. So let's look at least we cannot look at the entire issues here within this 20 minutes of my presentation, but at least let's look at some of the issues and be prepared so that we can develop from here. Now let's look at entrepreneurship. And talking about clean technology and green technologies, biomedicine and biotechnologies do play a role. And some of the examples that I'm going to cite later in this presentation will relate to this. Now, entrepreneurship is about creation of new ventures, small businesses. So SMIs have a role, and innovation, and taking it to a higher level where the bigger players and investors come in. So even if you do not wish to be an entrepreneur, the experience of applying these business concepts to a potentially real project can give some worthy transferable skills. So the question of translating a scientific idea to the industry and ultimately to the field, that are the different stages. Now let's look at the equity distribution as far as IP is concerned between the role players or the stakeholders. Perhaps this is just one scenario. There could be a university or research institution involved. There could be a researcher. And then you have the industry partner who could be involved in the scale-up. because most of the times the researchers and the universities do not participate in the scale-up. So you need an industry partner for the scale-up. And then comes the investors and the venture capitalists. And of course there are other stakeholders, because here in Malaysia, a lot of research funds come from the government, the ministries, education, science and technology. We got funds like the techno funds. And these funds, which the government have contributed significantly, they are also the stakeholders. So there must be a rate of return on that investment. And this is the valuable taxpayers' money. And therefore, it is a national asset. And therefore, it must be well taken care of. Now, what am I going to talk this afternoon here is just a few segments of the technologies. We'll talk a little bit about biopharmaceuticals, with which I have some good insights. We'll talk a little bit about bioremediation for the environment. We'll look at the biofertilizers for the agro industry. We look at alternative energy technologies such as biofuel, biogas, wind energy, and what is currently being developed at different stages. Some are successful, some are in early stages, but there are a number of significant players, no doubt about it. Now, let's look at the role of IP in innovations and commercialization. So here, I quote the co-founder and managing director of Arch Venture Partners, Robert Nelson. What are patents? They basically help to significantly mitigate the risk of bringing new inventions to the marketplace. And in fact, the private venture capitalists invest largely based on the strength of these patents. Without these patents, there would be no venture capital investment. And it leads to no job creation and no energy independence, and therefore no breakthroughs, including any breakthrough for climate change. So that's the role of IP in innovations and commercialization. Let's look at the case of one Asian success story in wind energy. And I cite this example where India is the current fourth largest producer of solar energy. And the Indian firm Suzlon is the largest wind turbine manufacturer in Asia. Now the company has a significant R&D footprint within India, and they have made a number of breakthroughs in the application of composites in the wind turbine industry. So Suzlon's world-class technology and the diversity of its innovation is tied to the IP that it has developed, upon which it continues to build. And the company has initiated cases to protect its own IP and filed for almost 20 patents in India during just the period 2007 to 2008, something to learn from. And of course, there is a lot of joint ventures happening across the borders in recent times, and that is why I'm citing this example. Now let's look at a case study of a private sector Malaysian agro project, which ran from 1996, and it is still currently running and successful. So I'm familiar with this, and that is why I'm just mentioning it. So don't get me wrong if I spend or delve a little bit of time on the technology. It is a self-sustaining integrated agro farm for good agriculture practices, and it uses some biofertilizers. And basically it uses anaerobic and aerobic bioreactors, where you can not just generate the biofertilizers but also the biofuel. And it is excellent for farm use, virtually zero carbon emission, minimum residue limit of chemicals on the agro produce, below the stipulated limit, what we call as the minimum residue limit, and very profitable on an 80-acre farm model, very promising. And it has gone global, Malaysian grown technology, something grown out of a Malaysian business model. It has gone global. They have set up a similar farm in Hong Kong, and they have had one in Yarra Valley, Australia. And the IP is still intact with the innovators. What do they have? Trademarks. They have some design patents. And I will just show some examples of this. Like for instance, this is the trademark, right? Just soil bioremediation methods, all right? Tested, proven in terms of yield. Is it expensive? proven to be cost effective. All right, even in Australia, it's about 550 Australian dollar an acre. Now, these are some of the infrastructure where you can develop a locally fabricated bioreactor such as this. This is not just used for biofertilizers, you can also use it for biopharmaceuticals. And you can have a design patent on this, locally fabricated, on the flow chart and the design itself. And you can have an excellent patent on this. And it is well protected. You can have a trademark attached to it. These are some of the other infrastructures for fertigation, the fermentation tanks. All these can be patented. All right, even the composting tanks, designed and protected by patents. So what is the achievement? High yield agro produce through application of biofertilizers, generation of biogas, very much useful for farm use, recycling of the farm generated agro waste, and similar applications are used on a plantation scale. And what does it do? Reduce the carbon emission. Definitely it is a solution for the haze problem. And the IP has been retained through the trademark and through patent design. It's still intact today, from 1996. This is the year 2014. Nobody has copied it. The investors are happy. Now, how does intellectual property rights influence the development and diffusion of green technology? One good example, the East Malaysian state of Sarawak may soon come out with a state-of-art technology which can turn oil palm waste into useful products. Who are the players here? University of Malaysia Sarawak, UNIMAS. Pansa Eco Technology Sdn Berhad and Bellwether Agriculture Private Limited of Australia. Very good joint venture with the blessings of the state government. All right? And it has come together to create this new technology since 2010. So, why the IPR? What is the importance of the IPR? Definitely, it protects the individual's creativity. And by protecting the creativity, people will be further encouraged to be creative. It prevents copying and plagiarism. And it prevents confusion in the marketplace. So, what are the IPs that are used to ensure incentives for investors in clean technology? You can use trademarks. I just showed one example. Patent designs on the infrastructure and whatever that you have. Trade secrets, excellent. Provided you are bound by a non-disclosure agreement of the players. You can have a memorandum of understanding or a memorandum of agreement. Now, I think MOU is not good enough, and MOA is better. All right? And that is legally binding. Now, what is some of the significant regional development? In June 2012, the People's Republic of China's State Intellectual Property Office initiated a fast-track examination scheme for inventions related to green development. And it covered inventions relating to low carbon emissions, energy and resource conservation, and environmental protection. My IPO is well ahead. They are very well in pace. And they have achieved some very good policies in place, and they have got some very good regulatory mechanisms in place. And your IPs are definitely protected. So there is no doubt we have come a long way, right? From the last 20 years, we have indeed come a long way. I'll also talk about biopharmaceuticals and the Malaysian SMIs, where natural products using indigenous plant extracts and even indigenous knowledge have been developed into nutraceuticals, registered under T for traditional by the Drug Control Authority. Then you have a lot of cosmeceuticals and topical applications, including toothpaste and other applications, which is classified under K for cosmetics under the Drug Control Authority. Now, why do I mention this? Because there is a scope for development. And this is one step before developing a biopharmaceutical. And it becomes a third clinical phase trial run product, ultimately, value added. So, why the Malaysian herbal-based nutraceuticals is important? Because it is a large revenue earner. About 777 billion in 2009, it is expected or projected to triple by the year 2020. Now, the shift of healthcare denoted by the global growth of natural products in nutraceuticals, there is a preference for natural products over therapeutic ones, because with therapeutic value, it provides opportunities for Malaysia to become a significant global player given our rich biodiversity. And there is sufficient statistics and information to justify this. Now, what is the challenge for nutraceuticals? And that is where international players and other investors come in. Diversification towards high-end herbal products, just one step away from clinical phase 3 tested evidence-based biopharmaceuticals on standardized extracts and validated by clinical studies, that remains weak because of lack of industrial champions, but weaknesses also in local R&D, which need to be enhanced, and large investment required for clinical studies. Now, that is huge investment, clinical studies, and also difficulty in penetrating international markets. So what are the opportunities? Opportunities, given the vast potential in market potentials and the support of providing alternative and complementary medicines and healthy living, the entry point project for herbal products towards nutraceuticals with claims and high-value botanical drugs have been identified. Again, the opportunities, incentives from the government, encouraging greater participation from the private sector in driving development of these high-value herbal products based on Ministry of Agriculture's Herb Sector Initiative as a new growth area. And therefore, the government will facilitate and support this project through the setup of a Malaysian Herbal Council. Now, the EPP is a private sector-led initiative, and it is aimed as a coordinated national project. And it has got the following objectives. 1, to increase the gross national income. 2, to produce quality, safe, and efficacious high-end products. 3, to strengthen supplies across the value chain. And 4, last but not least, to enhance R&D in herbs and secure the IP rights from local herbs. So the IPR is also achieved through a national branding policy. Government will facilitate an integrated marketing approach to promote a national brand. And herbal products developed under such project will carry a national brand. But of course, you can also develop your own individual brands. But this is an incentive given by the government, which shows how serious it is that they are taking it up as an incentive. So the branding is a very useful purpose. Now, the next thing I just want to talk very quickly is Jatropha, which is an alternative first generation feedstock. Now, this is grown in at least 3 locations, Sabah, Sarawak, and Peninsular Malaysia. I know of 3 locations where Jatropha is grown, and it is used to power simple engines, and it is a feedstock of choice from the EU without involving exceptionally large cultivation areas. And for this to happen, you need more improvements and expansion of areas, and you need a market for the byproduct, especially the glycerin. And biodiesel cost estimates using Indian Jatropha shows some variation, and probably it's cheaper than palm oil, and that is why we are developing our own Jatropha. And definitely it's cheaper than using soybean and rapeseed from US and Europe. And therefore, Jatropha as a feedstock for large-scale biodiesel production will lessen the pressure on other seed oils, especially food and feed and for other energy sources. Now, this is the prospect. For Malaysia is taking the challenge to further explore and strengthen the Jatropha production, especially through partnership with government agencies and with the private sectors. So there is a private sector biofuel technology that is under tight IPR protection. And refineries that require large investment up to about 100 million per facility located near biomass production areas. And capital intensity can be a driver in concentrating production in few countries. And the foreign direct investment is expected in biomass producing regions such as Malaysia. So this is overall the type of options that you have to protect IP as far as clean tech and green tech is concerned. So with this short presentation, at least I wish to convey these takeaway messages that green technology is viable, budding, and it involves sustainable economic projects in Malaysian and regional contexts. And some examples, And IP forms an important component for investors to be attracted to such technologies with incentives by any spin-off company. And a combination of cutting-edge technologies in green applications with IP and good business sense paves the path that is profitable and achieve a high rate of return. So with that short presentation, I would entertain some questions from the floor. Thank you. Please.
Prof, you mentioned about Jatropha, but how much has really been planted in Malaysia?
Well,
bearing in mind that it is, I think it's barred in certain countries because it is toxic, isn't it? Thanks.
I know of 3 locations where they are experimenting with the growth of Jatropha. I do not know much about the details of these 3 locations, but it is being tested and grown in 3 areas. So I'm not aware of what further developments there is in terms of Jatropha. But it is definitely grown in 3 locations as far as the source of information that I have. One is in Sabah, one is in Sarawak, and there is, I think, 1 location in Peninsular Malaysia. So I think they have to look at the details of the development of these projects.